Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events, and today is one of such events. We had a break with events for roughly a month. Now we're returning. And if you want to find out more about the events we have, there is a link in the description. Click on that link and you'll see all the events we have in our pipeline, which is not maybe right now. I don't think we published everything, announced everything, but we have quite a few events in the pipeline. And a couple of months ago, I went to Porto and I met a few amazing people. And finally, we are scheduling all these interviews with people from Porto. So today, Nemanja is one of them. But anyways, so you'll see more events also coming from that Porto conference. Do not forget to subscribe to our YouTube channel. This way you'll stay up to date with all our future streams, amazing like the one we have today. And we have a great Slack community where you can hang out with other data enthusiasts. During today's interview, you can ask any question you want. There is a pinned link in the live chat. Click on that link, ask your questions, and we will be covering these questions during the interview. And this is the last slide. I will stop sharing my screen. And now, if you're ready, we can start.
Ready.
Okay, this week we'll talk about machine learning engineering in finances, and we have a special guest today, Nemanja. Nemanja is born and raised in Belgrade, Serbia, but since 2014 he's living in Belgium, Leuven. Do I pronounce it correctly? Leuven.
Yes.
Okay. Yeah. So he's an electrical engineer who turned data scientist and then turned to an MLOps engineer. And this is what we will talk about today, machine learning engineering, MLOps. And I met with Nemanja on an amazing conference in Porto. When was it?
October 2023.
Yeah, it took a while to schedule this meeting. Yeah.
We were busy.
And there he gave a talk about MLOps. And I also had a chance to interview him, among other people, on stage. It was the first time for me. I interviewed people live on stage. That was a very interesting experience. So today we'll finally get back to this discussion and talk about machine learning engineering, MLOps, maybe Brazilian Jiu-Jitsu and Purple Belt. Who knows? So yeah, welcome.
Thank you. Thank you for having me.
Yeah. So before we go into our main topic of machine learning engineering in finances,
Yes.
Let's start with your background. Can you tell us about your career journey so far?
Okay. So it was a pretty, I would say, non-linear career journey. So I first obtained my, let's say, formal education in the domain of electrical engineering, as I already mentioned, in Belgrade, Serbia, where I was born and raised. And then my first job was actually a salesperson. I was like a traveling salesman for some automation equipment for the industry, for sensors and controllers and so forth. And then after that, I realized I don't want to stay in that career. I wanted to do something more technical again. And that's when I came to Belgium. And I actually came to do a PhD in the domain of bioengineering. So switching from electrical engineering to sales now to bioengineering. And there I stayed for about a year and a half. And I realized that, again, academia is not really a place for me, because especially I worked first a bit in the industry, and we didn't click, let's say, together. And so that's why I wrote, I'm a PhD dropout. I stopped with a PhD and I moved to Deloitte Consulting here in Belgium. And I stayed there for, I think, almost 3 years, then switched to a smaller consultancy called Data Roots. Not then, it was much smaller. Now they grew a lot. That was also a very nice time. From then on, I went briefly to ING. I worked before, sorry, I forgot to mention, I worked for BNP Paribas. That was my first experience in the financial industry. And then I worked for ING for a year. And now, hopefully, I settled in Euroclear in Brussels. This is a company which maintains the infrastructure for trading securities. So basically, I think like the easiest way to explain to people what we do is people usually know SWIFT, company which you use to send money internationally. which maintains this network through which you send, basically your money hops between different banks and lands in the right place in the end. But we are like Swift, but for bonds, for stocks and bonds. And so big companies buy and sell stocks and bonds through us. And we also keep national bonds for many European countries like Ireland. I don't know if is it Belgium and France and so forth. I will make a mistake here. I'm just the MLOps guy, I'm not the business guy. But yeah, this is where I am currently, and I'm in some kind of MLOps lead function. I would call it like that in Euroclear, and I'm helping to increase the overall, I would say, maturity, the MLOps maturity of my current company. And this is for the last 5 years. My title was usually a data scientist, but I was in practice an ML engineer. And so now this is formalized with the title also. We didn't call it MLOps 5 years ago, but it was just, how we call it, end-to-end machine learning engineering, machine learning. So yeah, that's it, shortly, my short trajectory.
And back then, like, I don't think even ML engineer, the role of ML engineer was actually there.
It was, I think,
it was more like data
first
science.
First time my job was called ML engineer was in 2019. And I know it was the companies that wanted to differentiate because data scientist, it was and still is, I would say, a very vague term. It doesn't mean a lot. So people use it to describe many different things. But when you say you're a machine learning engineer, it's pretty specific. You're not doing stats. You're not, you're doing machine learning. You're not doing dashboarding because people hire data scientists and then give them to do the dashboards. And so I like this term machine learning engineer, but still I would consider it a different role compared to a data scientist. But
yeah, definitely. Yeah. I want to add a few notes. So I see questions. So for some people, it might be confusing. So because here today in our community, and by the way, this for editors, please cut this later. So today we actually have a course launch. We are launching our data engineering course, and I see people who joined the stream today thinking that this is related to the course. It is not related. So the course launch will happen at 5 p.m. tonight. So this is just an interview. Sorry to disappoint you.
It's not a waste of your time. You can stay.
Yeah, this is a very good conversation. You will definitely learn a lot, but it's not about data engineering. It's not about the course. So this is a podcast interview. So now I hope the count of people who joined will not drop too much. And then another thing I forgot to mention, because it has been a month since the last interview, I forgot to give a shout out to Johanna Bayer, who helped preparing all these amazing questions we will talk about today. So thanks, Johanna, for your help. And for editors, please move it before the first question. Okay, now we continue. So by the way, so your first job as a kind of data person was Deloitte, right?
I would count already the PhD.
Before
because
PhD.
In Belgium it's like a job of a research and teaching assistant, and there was a lot of data science, the modeling, systems modeling, and control, and that's when I started using Python intensively. And already I did it before, but that's when I was getting paid to do Python.
Okay. And Deloitte is a consulting company, right? So you probably need to speak French or
no?
Sure, no?
No, actually not. In Belgium, not really. It's desired. It's always advised, and I think it will certainly open up many more doors if you speak the local language. But in Belgium, it's Dutch and French, and you should speak English. But for the more technical positions, like technology consulting, it's okay if you speak only English. But for certain clients, for example, if you're working with the government, you need to speak fluently.
Or NATO, right? I remember this. There's headquarters, right?
In Brussels is the NATO headquarters.
Yeah, I remember going from the city center to the IBM office and the NATO. Like it's huge.
They have a new fancy building, even fancier one. Yeah.
Okay. Yeah. Anyways, so you have worked at a variety of different companies: Deloitte, ING, Data Roots, BNP.
Yes.
Now it's Euroclear, right?
Yeah.
So most of them, if not all, involve finances and banking, right?
In the last 4-5 years, yes. So not all of them, but yeah, I worked also with at Deloitte. You're a consultant, you switch companies relatively frequently, and so I worked also in the how do you call it, biomedical, for the vaccines, GSK, GlaxoSmithKline vaccines. We also did projects with Amazon, with ABB, which is the industrial manufacturer. So there was a lot of variety there, which would take time to mention, but yeah. Let's say I settled the last 4 or 5 years in the financial industry. That's important.
So what are the typical problems that data scientists, machine learning engineers, or MLOps folks usually solve in the financial sector?
You mean use cases? So let's say from the business perspective, I would say there was a clear common line between all the companies where I was in the financial industry. Okay, on one side, all of these companies have very strong regulation and they have very strong compliance requirements. So these fraud and money laundering cases are always there. It's simply imposed. You have to do it. On the other side, I think where most of the business value comes from. So for this compliance, fraud, AML, you have to do it. If you don't do it, you have to pay like billions in fines. But it's like an overhead which does not give some concrete added value, just saves you from a certain very big penalty that you have to pay. On the other side, things which really give value in the financial industry are so-called smart automation projects. And in essence, it's usually processing semi-structured and unstructured data, like documents, like emails and so forth. And whether it is like information extraction, extract an account number, extract a signature, route the email or a case to the right department. It's also very important. And all these companies have a lot of people who are manually processing all these things still. There is still a lack of, I would say, proper forms for data information. So things are arriving in some kind of semi-structured, poorly structured formats. And then you have a lot of parsing, a lot of interpretation and so forth. So those are the main things I would say. Definitely, I think it's 80-90% of cases that we work on.
So first, regulations, compliance. If you don't do this, you get a huge penalty. So you kind of like all the companies have to do that.
Yeah,
they don't want to lose money. And then the second category is more like internal, right? So I imagine
it's like process efficiency. It's really, but in the end, it impacts your customer also, because if you're doing this slowly and manually, the whole case processing takes a lot of time. So. The faster you can do it. Also, I didn't mention RPA. This is not something I do, but robotic process automation is also very big in the financial industry. The thing is that what also connects all these companies is that they were in some way all pioneers of this like digital era, and they all had very early their mainframes and all the digital frameworks, and this is now a bit of a curse. So because they had all those systems, they were the first ones to have all those systems. They have a lot of legacy code, they have a lot of legacy infrastructure, and it's very hard to modify, to improve many of these things. They were not really built, let's say, in a forward thinking, in a forward compatible manner. And so now that's a lot of let's say trouble is caused by that fact.
I imagine there are also some customer facing applications, like I want to make a transfer, and then I have an app, and then they just take a picture of my receipt.
The mobile applications are also a big thing. Yeah, indeed. You see a large variety. So maybe the mobile applications I mainly saw as a user, because I'm currently using 2 banks in Belgium. I could see there is a big difference. Some banks really pick this really, I would call it lean, simple approach, like ING in Belgium, and like KBC Bank takes the completely different approach, where they put everything in the app. Literally, I think you can almost make lunch for your kids in the app. It's like you can pay the parking, you can pay the train tickets, you can order food. I think you can do so many things in the KBC app and in ING app. They've just chosen this, like, we just give you the banking thing. So it's they have their reasons probably.
Yeah. And as an MLOps person, ML engineer,
Yeah.
what do you actually do? Because I imagine like we talked about more use
Yeah.
cases, but then like as an ML engineer, MLOps person, you don't work on the model that,
Yes.
I don't know, recognizes the account details, right?
Yes, correct. So that was the second part which I wanted to say. So on one side you have the typical business use cases, and the other side you have the typical work of an ML engineer in finance, which is mainly, I would say, mainly modernization, mainly getting things to work. And so in general, an MLOps engineer is a person that, in my view, tries to abstract all the non-modeling part of work from the data scientist. So my idea is I want to be like a kind of a service to data scientists to make like kind of a platform or a framework so that they can focus on their data science, the difficulties that they have in extracting the right entities and making the right models. And then I basically handle all the rest. I give them like a standard full project structure for the project. I give them. I am the one that makes the.
And them
Sorry,
data scientists or who?
sorry, I didn't understand the question.
Yeah, you give them, you referred,
Yeah,
you said to them, like data scientists, right? Or who?
yeah. Get data science. We work together in a team, so we have usually like
Mhm.
2, 3 data scientists and an MLOps engineer per project,
Mhm.
and we work together. It's not like passing things over the fence.
Mhm.
It's
Yeah.
really working together and reviewing the code together, and everything is in very closely coupled. So, but yeah, my part is create the repo, create the project structure, create the CI/CD pipelines, figure out how do you need to deploy. What will be the target deployment platform for this? Will it be the cluster, or now we are looking into some also like the cloud? One also thing to mention here, like a side note, in financial industry, I think still it's mainly on-premise architecture. So there are some movements towards the cloud, and there's like I would say definitely a persistent direction there, but still there's a lot of core systems which are on premise. So yeah, for me it's also, so will I deploy it on the cloud, or will I deploy it on the on-premise cluster or on the OpenShift cluster? And then there's like networking. How do you open up certain firewalls for this application to communicate with this API? And yeah, on and on. Those are the main things.
So it sounds like it's more or less a typical job of an ML engineer, except that you, like you said, that there is a lot of modernization work, which I don't know,
Yes.
like depends on
Yeah,
the
yeah, it is. But
organization.
I think definitely the ML engineering role is like a software engineering role,
Yeah.
which is very generic. And the more you go to data science, the more it becomes business specific.
Hmm.
And I can really see that I have very little exposure to the actual business side of all the projects, which I miss pretty much. When I was doing the data science work, I was always much deeper into communicating the communication with the business. But here, no, I can live in my bubble of of code and the DevOps platforms. So yeah, it's pretty much similar. But yeah, there is this thing of modernization, of change management, of seeing how to now fit MLOps into the classical DevOps, because these companies have a pretty established DevOps practices and governance. And now you need to see how to somehow integrate, how to smuggle in ML in this whole thing.
And these existing DevOps processes, platforms,
Yeah.
existing governance,
Yeah.
like what is it there? So I assume that it's not like the most modern solutions. Probably it's like time-proven things that you mentioned OpenShift. It's
Yeah,
pretty old
it's a mix
technology,
of,
right?
it's really a mix of things. So
Mhm.
I think when they buy something, it's the newest one. It's
Mhm.
usually, so when they say now we're gonna go with this, we
Mhm.
take the best one. But that will probably not change for the next 10 years
Mhm.
or more.
Yeah.
That's the thing. So the things are slowly moving, slowly changing. And I think just the landscape, the internal IT landscape is so big that everything has a big impact, and you already have a lot of applications. So to move, let's say, from one logging, like centralized logging, we have Splunk now. And so this is a modern solution, I would say. I don't know if there's something especially better. But imagine if suddenly you want to switch to another thing, that would be a big cost, you know. So that's I think the main issue, the main obstacle there is the slowness, and the whole planning needs to go into big time windows.
Mhm.
Yeah,
Is it specific to the financial industry, or it's more like maybe
I
more
think
traditional corporate environments?
it's not in all corporate environments. No, definitely not. I think it's very specific to the financial industry. I think for any over-regulated industry, any industry which has like a very big involvement of regulators, of governments and international bodies, they are very, very risk averse. So it's better not to do something than to introduce some kind of a risk. And in these companies, you also have all these trainings, like every month or so you have some kind of a risk training, how to spot risk, how to handle the risk, how to manage the risk mitigations everywhere. And yeah, you learn to always think about that.
Yeah, I remember I worked at UBS. That's a bank. I think it's United Bank of Switzerland. Well, it doesn't matter. It's a financial institution. Very conservative institution. I was there working as a Java developer, and we would release every month. And if a release doesn't go through that month, it means it will go the next month.
Next month, okay, we're not that rigid. So for us, it's still the release cycles. Yeah, there's a whole department which is called change and release management. And when you want to release something to production, you first need a review like from your own team. Then you need to create this kind of a change. And you need to say which exact commit, which exact build will you release. And you need to show that it was first released to test and that it worked. And that this was released, let's say, at least a week before the release to prod to test, that it was properly tested. And then you have like some 3 different teams where one person from that team needs to approve, yeah, there are these, but if it failed, you can do a rollback. There's like a procedure to do a rollback, and you can have like an emergency change. If it's like shortly, if you need a bug fix to do something, you can have an emergency change. Of course, you need to follow the procedure for the emergency change then. But yeah, the important thing is for them that you always know what is in production and who put it and when they put it. And
okay, so these are existing DevOps processes and the governance framework that you mentioned, right?
Yeah.
Which sounds like a bit of a hassle, to be honest, right? But
yes,
like there are reasons for that, right?
It slows you down, but I would say you learn how to do it. You learn how to do it quickly. It's every time it's faster because also you get first time you do it, people don't know you. It's all about people trust. And the first couple of times, people are really looking at your pull requests in detail, and you're changing. What is this guy doing? Who is this guy? What does his code look like? And every next time when you start deploying frequently, you get all these approvals much faster because people say, okay, this guy never crashed anything. There were no incidents and so forth. And you know who to ping. It's even like the people connections. You really know who to ask on MS Teams. Hey man, I have this change. Can you please approve? And so yeah, lately this was not really an obstacle. Yeah, in these corporations, it's always you need to know people. You need to after a couple of years, you become really productive when you really make your network, and then things start going very fast.
Yeah, and I imagine since there are these processes that were set up like ages ago, and they're thought through, and they exist for a reason. And you as an ML engineer, MLOps person, you need to stick to these processes, right? So you work on MLOps, you work on these machine learning pipelines, CI/CD pipelines, or whatever, and what you do need to stick to the guidelines from the DevOps people, right? How difficult is this? Like how difficult was it to map like the MLOps processes to this DevOps framework?
Well, I would say that we still are not there where I want us to be, definitely. So there is still improvement there to be done. But it's a journey. It was in the beginning, as I said just a moment ago, it was hard at the beginning, but luckily, I did not come into an empty room. So there was already people in the company who did a lot of previous deployments. So we, let's say, piggybacked for a while on the team of data engineers who are doing really frequent deployments. And so they explained us, they guided us through the whole through the whole process, and until we became independent to do it ourselves. But yeah, you know what we say, a living person gets used to everything. So this is also true here. You stop noticing it at one point. You know, when I talk to somebody and they hear, for somebody from a startup, and they hear, oh, you have to do all these things. For us, it's no longer something which is an issue. You know, it's like, okay, this is how you do it. It's more like muscle memory. You know, you click here, you make this, you prepare that, and you go to production. I heard much worse stories from certain companies where, yeah, you have to literally have like a sheet of explanations for every little change, and you need to use like this, whatever is it, Jira tickets or some kind of service now. TFS tickets, what doesn't matter, but yeah, there is much more bureaucracy in certain other places. So I think we have a decent sweet spot here. Yeah.
Okay. Yeah, I remember. So back to my UBS experience. It was, to be fair, it was a long time ago. Like it was 10 years ago or more. So then there is a comment that today in finance, luckily CI/CD is a part of daily routine, which is a good thing. I hope it's everywhere. But I remember one thing, that we were super careful with open source tools we used. And like we had to do these things you mentioned, but instead of like every change, like if we want to introduce a new open source package that wasn't used before, library, that we had to write an explanation. Why this library? What kind of license? Is it a good license? Like, do you have?
Yes, there is to a certain extent, but currently the default is that we have Artifactory, which is like an internal package registry, JFrog Artifactory, and it mirrors the public pipeline. And I think only if it registers some kind of a vulnerability, some kind of a critical vulnerability, it's going to blacklist a certain package. And recently there was a situation where I wanted to ask for another package index. So not a package from PyPy, but it was a separate index. And there I had to give an explanation, but it was like a short chat. The person that was in charge of this could really just fill out the form, and then it worked. So it was not too hard. Yeah.
Okay. So I imagine if you want to use, I don't know, PyArrow instead of plain pandas, you don't.
No, we don't have no. It's okay. We don't have an issue with that. Yeah. But if it's like a completely separate thing, which is like not on any kind of a public repository, then you have to justify why you need to manually import something. Yeah.
And how difficult it is to work on premise. So I imagine that there is this OpenShift cluster, and then like I guess there are all these procedures, standards, templates. So like it should be pretty smooth, right? Or
yeah. So currently we are working mainly on like a classical, I would say, Hadoop cluster. So there's the OpenShift cluster is something next to it. We're not currently deploying there, but yeah, there is like a certain kind of a project structure for deployment there. There is a standard pipeline if you want to go there. So it's pretty much already, I would say, ironed out by the data engineers before us, and we are just reusing that same approach. And working on premise is, I don't know, I like it. It's like really close to the metal. It's simple in a way. Yeah, you have the machine, you have the operating system, and you don't have all this array of services that you have on the cloud, which are also helpful, you know, in many cases. But you get to learn a lot about like Linux. You get to learn a lot about Bash scripting, about networking, SCPing, SSHing, and these things. And yeah, I like it. I got used to it, but it's I would say much simpler. In ways much simpler, but in other ways it requires, I would say, more knowledge of computers and operating systems, like of Linux and networking. But that's the main difference, I would say. Yeah.
But do you actually need to order hardware? Like, imagine that you want to deploy anything.
No, not my team. Not my team. So there's a whole. The thing is like platform and on-premise requires a team to maintain that infrastructure, and that's the main deal with, I would say, smaller companies, is that they would have to hire somebody to maintain a data center. And for smaller companies, it's a problem. For bigger companies, especially in the financial industry, that's really not the problem. So I think that's the main attractiveness of cloud comes that you can easily start and have some kind of a data center, a rented one, and then you can expand it and so forth. But recently we had there was a certain number of machines being added, or you say, oh, I don't have the capacity, and there's like a whole team which manages that. So there's like a platform engineering team. You say, guys, this is what we need. Here's the money, and please do the work. And they just tell you, okay, now you have all these machines added and include them in the pipeline. That's it. So,
so for your needs, you can just assume that it kind of works like cloud. When you need resources, you'll have them, unless it's like super gigantic that you need to ask in advance.
Yeah. So in a way, it's like a cloud, but you don't have like you don't click and make things. You ask people. You make a request to the people, and they do these things for you. And usually, that's also one of the things, like to find the right request to make. To know who is in charge of what and where. That's a bit of it's a journey to learn and understand. Yeah.
So we met in Porto at a conference, the Data Makers Fest, and you gave a talk.
Yes.
And it was a very nice talk. So I attended that talk. I think I was even a moderator. I don't remember.
Yes, you were.
Yeah. And in that talk, you showed that you don't need a lot of fancy stuff to start with MLOps, right?
Yeah.
So maybe can you give us the main ideas from that talk? And what is also interesting for me personally is like, how did you arrive at this idea? Why and what it cost you to?
So it connects with my experience in the financial industry.
Yeah.
So the title of the talk was MLOps on a Shoestring. And I think it's now, since 2 days ago, it's available on YouTube. If you Google Data Makers Fest, Nemanja or MLOps.
We will put it in the description.
Yeah. It's there. So basically the idea was, as I say there, we all operate on a certain budget. And so it can be a time budget, it can be a money budget, whatever, or people budget and so forth. And if you're in a large organization, you want to implement MLOps, you need some kind of a prioritization schema, some kind of prioritization exercise. And that talk was about that. Like, how do you start? What would be the minimal set of MLOps features, of environments, of components that you need to implement in order to say, okay, now we're doing some kind of MLOps. And if I remember correctly, I don't want to repeat the whole talk here.
Yeah.
But in general, we said, okay, first thing, you need to have a development environment and a production environment. That's the basic thing. And ideally, you should have a test environment so that you can independently develop, independently productionalize, independently test. In the middle, as the central control tower, you need to have a DevOps platform where you integrate all your code, where you launch, where you have the whole audit trail of all the changes of what anybody did. How I called it then, I remember cover your ass ops, basically, in order to play the Git blame game, ultimately. And next to that, you need to have, I would say as a very bare minimum, you need to have some kind of a monitoring solution to know if your application is alive. If it just dies, it will not tell you that. You need to have, I would say, a model registry, and you need to have some kind of a version data registry. I think that was one of the things I stressed 2 times. And this is also something where it's often like an afterthought that we don't realize often that data produces code, and that not versioning data means not versioning your code in ML. And so that was one of the things. If you want to have what I call the crown jewel, which is having reproducible ML pipelines. So and why reproducible ML pipelines are necessary, not because you will actually have to reproduce a model. I never had to reproduce a model a year later or something. That was never a requirement. They always say, yeah, we should be ready to reproduce a model. But actually, if you can reproduce a model, that means you have control over your ML process. That's the main thing. So that just proves that you know what you're doing. And if you cannot, then who knows what's in production if you cannot reproduce anything. So that was the main thing. It was not that I did not say, oh, you should do it like this, and this is you should stop here. But if you had to choose the minimum set of MLOps components, that was my proposal. Yeah.
But not only that, now if somebody has not seen the talk and listens to us talking about that, they imagine like this complex thing with all these tools that do like all the things that you mentioned. But what you showed us in the talk was that these components, although they sound like complex, they are actually not. And you can start super simple.
Yeah. Like for the model registry, as I said, the model registry can be just an S3 bucket.
Yeah.
And that's okay for beginnings. I like this. This is more like how they call it consultancy talk. I learned recently, relatively recently, a term they call a tactical solution. And it's basically an ugly solution which works until you reach your strategic solution. That's why it's called tactical. It's like you have what you really want is like, I don't know, MLflow or Databricks. But in the meantime, you have just some kind of a mess of whatever Excel files or something. Then you call it a tactical solution. Immediately sounds like a solution and like something tactical, something clever and thought out. So I would say this S3 bucket is a good tactical solution for a model registry. Yeah, and also for versioning data and for whatever.
Yeah, I love how it sounds, tactical solution. Just you would call this temporary solution, air quotes temporary, but like then 5 years later, it's still there.
There's the famous quote. They say there's nothing more permanent than temporary solutions.
Yeah. So there's nothing more strategical than a tactical solution. Okay. That's nice. Okay. Yeah. And so what led you to this idea? Like, what did you see in your experience to give this talk? So what did you see in your experience that caused you to...
As I said, I work in the financial industry where you're moving very slowly. So imagine, you have a bunch of bad guys and every bullet costs you 10,000 euros, so you need to think very carefully how you're going to use your ammo, and so that was the thing. So what is the bare minimum so that you just tick the boxes and that you can say, okay, I'm safe. My process is controlled. I have reproducible training, and then I will move forward to like user experience and have, a nice dashboard. For example, if you need to implement monitoring, your boss says, hey, do we have monitoring of our ML models? At the very minimum, you need to have some kind of a log of your models and of their predictions, even if it's in a text form. You can spin up a Jupyter notebook and analyze, but if you don't have that, then no Power BI fancy dashboard will help you. So, start from the very bare minimum, so to cover your butt, and then move forward to the fancy things and making your life easier.
So the idea here, if I try to summarize, the idea here is to kind of close the loop on the process as far as possible. So you have a process.
Indeed, to have a complete framework in a simple manner. It's like what they in Agile, that whole thing, which I don't really like Agile, but I like this. I don't call it Agile. I would call it the prototyping approach, which means you make a first end-to-end prototype, and then you iterate and improve bits and pieces. But as a whole, it needs to be. You cannot have a Porsche without one tire, or So you have the fancy doors, you have the fancy motor, but without one tire, it's not going to go. Huh? So first make it, operational, and then pimp it.
Okay. Yeah, I like Agile. I mean, it's good to be able to start. Like, let's say there is a new team, and you want to make sure the processes are there, so people know that what they are doing is not chaotic, right? So you establish the framework, you start using it, and then you make it complex as you grow, as you become more mature.
Yeah, but I would say the main issue I have with Agile is that it forces you in a way to try to make something. I would call it like demo-driven development. So like you need to immediately have something to show, and then I think it forces you in a way to create some kind of technical debt, because you want to make something quick and dirty, and you're thinking from demo to demo. And if your sprint is like 2 weeks, I think the beginning of a project should start in some kind of not a waterfall mode, but something like, okay, let's set it up. Let's set up the groundwork. If you're building a bridge, you cannot first throw a log over the river and then build a bridge on top of that log, So you need to do a lot of groundwork and things. You cannot do it in sprints, So in many things, it's also like you have the standard, the diagram which they show in Agile trainings. Like you have first like a tricycle, then you have a bicycle, then you have a car, then you have an airplane. But what I always ask is like, okay, have you ever seen an airplane which started as a tricycle? It doesn't exist, So at one point you had to break down the whole tricycle and make an airplane. So I think that's a bit of.
I see what you mean. I mean, we can just say everyone can deploy to production whatever they work on. It's kind of a process, right? But like, does it bring us anywhere? So you need to.
What do you know? What do you really know about a complex problem in 2 weeks?
Yeah, right.
I mean, there's so many things to explore, and I'm fine. I think you can set up some kind of, if it's like the fifth project you're doing, if you're doing like some kind of a mobile app or doing something which there is a certain kind of, like, say 50-60% of it you can already start and do it, and then later you will tweak the GUI or something, fine. But in machine learning, so many times takes you a month to get the data, to understand the business, to do this and that. So on my MLOps part, okay, I can make immediately the project, I can make CI/CD pipelines, I can make the API function, and then have like a hello world model say hello from the API. But then it's going to wait for a month or two for a concrete model to sit in there. So certain parts, yes, but the exploratory research and development things, I don't think they fit very well into the whole agile philosophy.
Yeah, that's why you have 2-3 data scientists per one ML engineer.
Usually, yeah.
Because doing the data science stuff takes more time.
Yeah. Indeed. Because there is my work is usually more reusable. So they all develop similar models, but they all have to go and to talk to other people in the business and understand their needs, and back and forth. They have many more meetings with the business people than I have. I don't have meetings with the business people. I just talk to them, the data scientists. And there's the data, there's the cleaning, the understanding, and this iterative process is much more. For me, it's pretty exact. My API works or it doesn't work. And, it doesn't deploy or it doesn't start, or, it's very, I don't need another person's opinion to know if my API works, or authentication or whatever. So that's my fortune, I would say.
So if I overly simplify it, then let's say you have 3 data scientists after a month of work. They come with 3 models, but your role here is to make sure that all these 3 models can be deployed in a similar fashion. These 3 models are different. They solve very different business problems, but your role is to make sure that there is one platform, one piece of infrastructure, whatever, where all these 3 models can easily fit. And for you, it kind of doesn't matter what these models do.
Indeed. I mean, we agree from the beginning. We say, okay, let's see what you want to use. Do you want to use Spacey? Do you want to use Scikit-learn, PyTorch, and whatnot? And then we immediately start to accommodate for their approaches, their ML frameworks in this overall framework. And also a lot of my work is really like code review, like also the ML code review, because you don't want, I don't know, just any kind of code there, like data pipelines. I try to make sure that they are always modular, that they are testable, that they are, not like just one giant script. And so there's really a lot of interaction. And it's not really a one-way process, because also when I have my own pull requests, I also submit them to review for them, because they also use Python, and they also help me sometimes spot mistakes in my code. So yeah, it's really like it's really like a teamwork in that sense.
So do I understand correctly that you have kind of 2 categories of work? You have the platform work, and then you also have like the code standardization kind of code review work, where you help data scientists with their projects. And then in addition, you maintain the platform where data scientists can deploy their...
Well, I don't maintain really the platform. So what I actually created in this company, it's like the approach, and so I maintain the applications in production. So I'm the one that deploys, and I'm the one that pays attention if there's alerts, if something doesn't work, and I go there, and if I need to fix something, that's what I do. It's not their problem. But the platform is, like, in terms of the hardware, it's not my part of work. But I also something
more like an approach.
Sorry?
It's more like not a physical,
okay.
like
indeed.
It's more like an approach.
Yes, indeed. And there's also like a library which I'm maintaining with my fellow MLOps colleague, which, let's say, we created this library, which is like a framework on top of Fast API, which then also allows for simpler let's say, creation of new projects, because we saw, okay, every other project we're doing this, and so we put it all in one library so that tomorrow data scientists could maybe even independently create a whole API with their models. That would be some kind of ultimate goal. Yeah.
Okay. I noticed that we have quite a few questions from the audience. So the question number 1 and 2, I'll combine them. What kind of programming skills and soft skills do you need to have as an ML engineer?
Okay, so I think ML engineering is first and foremost more on the hard skill side. I think it's very close. It's very distant from, I would say, data science. I think it's useful to know data science because you need to talk to data scientists. They're your clients. Let's call it like that. But I would say Python programming. If you're in the cloud, then knowing the cloud services of that specific cloud you're working on. If you're on premise, then it's Linux commands, Bash scripting, networking, a bit of networking. You don't have to be an expert, but yeah, to be able to survive in that environment. And so that's when just working on the projects. But I think also soft skills are important for this change work. I would call it like that. For if you want to bring something new to your company and you want to raise the maturity of MLOps in your company, you need to have this kind of evangelical trait to go around and, missionary, how to call it, you need to go around and talk to people and bother people and ask and pull their sleeve. And you need to be persistent. And then ultimately a nice person, not get into conflicts with people because you're annoyed something doesn't exist.
But just in case you have Brazilian Jiu-Jitsu.
That would be the end of the story. I would not get anything. I would not get a simple Python pipeline in the end. But yeah, I think it's these skills are important to create a change in any kind of organization, to be able to build networks and present things. If you want to get a certain kind of, let's say, I don't know, you want to get a fancy vendor-based project, model registry, you need to convince your boss, and your boss speaks business language. And so that's something I want to make a talk out of, is like how to change hard to change organizations, and how to really sell internally certain technology solutions and how to fight for those things. And one of the main things I think is to align your goals with the goals of your superiors, and to speak their language. And if here it's like, I don't know, I said in financial industry it's about risk. So if you can show how your solution reduces risk, for example, for the company, that's what they like to hear. That's what they can sell upwards. So you need to help them sell that upwards. And I think those are the main skills.
Mm-hmm. That sounds like your skills, your experience working as a salesperson helps now, right?
Yeah, a bit. That helps. Consulting also helps, because in consulting there's a lot of sales also. So in consulting, like you have like a day job of implementing the things you need to do, and then you have a lot of work in selling new proposals to new clients and explaining how you bring value, how you do this and that, and that there's always this translation work there. If you just talk about technology, nobody cares. I mean, nobody cares. It's hard to follow, but if you
data scientists maybe care, but if you talk about top management, they care.
The people that open up the purse, to pay for your solution, they want to know, how do you make me sleep better at night? I think that's the that's the main thing.
Yeah. Okay. And there's an interesting question from Deborah, which we talked about sales a little bit. So what was the most challenging aspect of transitioning from doing sales and doing electrical engineering to machine learning role, especially in terms of technical skills?
Well, I think for me, the sales part was more a deviation in a way. So already my, let's say, formal education in electrical engineering I already had machine learning there. I already had a bit of Python. Okay. Yeah, so I'm electrical engineer in the domain of signals and systems. So it's like systems modeling already. That's something I already did there. Machine learning was like still an emerging term. But then later, when I started doing machine learning, I was like, oh wait, I know these things. Like we have, the mathematics, the signal modeling, signal processing. Control. On top of that, we did control. So how do you go from modeling a system to controlling a system, which is, I would say, an extra next step. So for me, I can't say I had some kind of a big struggle and battle to get into it. But for me, maybe the hardest thing for me was understanding this like probabilistic way of thinking, because most of my engineering was like, it's really exact. You calculate a number and you calculate a solution to this, and then to understand like distributions and how, for example, you add two probabilities. I still remember that I just could not get my head around it. Like, when you have one distribution and another distribution, if you add it together, is it one on top of the other? Is it like, how does it look like? And I remember, I was actually arguing with my professor and I was wrong, but I was convinced he's wrong. But yeah, he found a gentle way to tell me no.
Yeah. That's why that person is a professor, right?
Yeah. It could have, come to my mind maybe, but no, I was so convinced that he's wrong.
But sometimes it also helps not to, how to say, put anyone on a pedestal just because of their formal role.
Yeah,
right?
Yeah, indeed. But this guy,
being a president doesn't mean that they're right?
Yeah.
I guess for you, this sales role, this deviation that you mentioned, was more difficult than transition.
Yeah, I mean,
okay, like it's so different.
Yeah, so it's been like a first job. I was like, okay, let's do something, whatever. It's close to it was sales of the technical equipment, So what I should have programmed, I was just selling that, And I was good in that because I was not a typical sales guy, because I was like a nerdy guy that actually knew the equipment. I actually knew what you need to do with that, and then the technical guys I was selling it to, they were like, "Oh, you really know something. Oh, you have a degree," because and so I could help them even configure, and I even helped them solve technical problems with that equipment, and that's something they appreciated. And I would say, if we were talking about business-to-business sales, like this was, it's very important to work on long-term relationships and not just like push to sell, but really even to decline a sales if you really think it's not solving somebody a problem. Yeah.
But I imagine the work of an electrical engineer is not actually soldering components, but more like computer, right?
That's an electrician.
Yeah.
But electrical engineers, I mean, you have like the power line, you have the high voltage electricity, you have microelectronics, you have like the physical electronics, biomedical engineering also was there. So we learned about like medical imaging, for example. That's also very interesting domain. But yeah, it's not soldering.
Okay. Okay. Another question. What is the general tech stack for machine learning for a novice/beginner?
Sorry, again, you repeat? What's the?
Yeah. So the question is, what is the tech stack for machine learning for a novice/beginner? So I'm just wondering, like, it's quite a broad question. So I guess the question is asking what kind of technology, if you're a beginner. Tech stack, yeah. If you're a beginner, you want to go
for beginners, I would still say Python above everything. So Python is like definitely like the glue language which connects everything, and it's even getting injected into browsers and into Excel recently. So I think you cannot make a mistake if you invest your time to learn Python properly. I don't know, with libraries, it changes all the time. It changes all the time. So your basic skill needs to be Googling. And being ready to change. SQL is definitely something which stays. Like Pandas has like a long tradition, but now you see people using more and more polars and this and that. But still, you see that Pandas has such a strong legacy that some other projects have accepted the Pandas API, like the Pandas way of doing things, although it's not Pandas. Like on PySpark, I think you have now also some kind of a Pandas API. Like you can use Modin on Ray also as a Panda. It looks like Pandas, but it's not Pandas, So in that sense, I think it's also just fine to start with that. But I think it's good. I would say open up the job postings, and look what people are looking for.
Yeah,
You know,
that's
definitely.
usually the best
And
advice.
search. That's like how I did it every time. You know, you open it up, and for example, how I started learning Python is at university we did a lot of MATLAB. You know, and I was like, okay, I liked MATLAB actually. It's a really cool tool. But then I was like looking for jobs, and I was like, okay, who looks for MATLAB person? I was like, nobody, apart from some German car manufacturers or like part manufacturers for cars. Nobody was using MATLAB, and I was like, let's look for the positions I want. Oh, everybody asked for Python. Let's learn Python. You know, so and I would say don't obsess. I would say know one tool maybe across the stack that would be good, and then they are all pretty similar. You know, in the end, it's easy to transition from one to the other. Yeah, scikit-learn, pandas, Python, those are the basics, and still they're being used everywhere, and all the rest is, I think, just derives from there. It's good to know to do something in the cloud. So I had a lot of pet projects. I made like websites. I think it's good to know how to make a simple website, like just basic HTML, CSS, JavaScript. It can look as ugly as hell, but if you know just a bit of that, how to compose everything together, I think it's valuable. Depends on how much time you have. If you have unlimited time and you're young, I would just say go wild and learn everything, you know. But but yeah, focus on projects, focus on making something end to end, and you will see what's required there. You will be forced.
Yeah, I think that's the best. Like instead of thinking what kind of tech I need to learn, think what kind of projects I want to make. What kind of problems I want to solve. And then okay, like this is the problem I want to solve. Like I want to, I don't know, detect when if I had a cat, and then like the water for drinking is gone, right? It's not there anymore. You maybe want to detect that moment, right? So then you have an idea what you can implement, and then you think, okay, what do I need to implement that?
No, but the thing is, I think it's mainly a question about not what's the best tool for the job, because you have many, for each domain, you have many tools which are good for the job. But then the question is, what will get me hired? I think that's when I think about what to learn. I think what's going to increase my chances of getting hired. And then you need to just explore, be a data scientist about the tech stack. And what's the best way to be a data scientist about the tech stack is to go and look for job descriptions and see what people are asking for. And always know that every job description has 3 times the actually needed stack. So if they find somebody that knows a third of that, which they ask, they will hire him immediately. They always just write the nice wish list for Santa, but nobody knows all these things. So, and in the end, Googling and thinking, I would say thinking on your feet, this is usually what gets you.
I think I remember, so for my first job, well, actually I was already on my first job. For the second job, what I did, I was a Java developer. So I opened like 20, 30 different job descriptions and then noted what is common among them. Because like every single them had a job, which had a tech piece of technology that no one else had. And then like
there's a data science project.
Right?
There's a data science project. Make a web scraping application which scrapes whatever LinkedIn jobs or monster.de or whatever you're using, and do some kind of NLP and analyze what are the best, and make a website out of it, and you can maybe earn money out of it so that people can every day follow the trends in the tech stack per domain. You say, okay, for a machine learning engineer, these are the most common keywords, excluding the stop words, of course. And there it is. We just gave you an idea. Perfect.
That's cool.
Pay us when you earn money. Give us a cut. We have the recording.
Okay, I think that's all we have time for today. So we should be wrapping up. So thanks.
Thank you.
It's always a pleasure talking to you.
Likewise.
So, thanks for joining us today and sharing your experience with us, giving all that advice. So thanks a lot. And looking forward to connecting with you again, either in person in Porto or on some other conference or elsewhere. So thanks. And thanks everyone for joining too. Everyone. So bye.
Ciao.